This question is a bit difficult question, but if you solve it, keeping in mind the small things, don't miss out on the small things and you will get the right answer. Now in this question, both these blocks have been given an initial velocity v in the right direction. The frictional coefficient between these two blocks is mu by 2 and the frictional coefficient between block and the ground, lower block and the ground is mu. We need to find out the time before the two blocks separate. Now we know that frictional forces will be acting between these two blocks and this block and the ground also. Therefore, let us find out the normal reaction between the two surfaces first. This block of small mass m experiences mg in lower direction and a normal nb in upper direction. This is normal reaction due to block. This nb equals mg. Now consider the lower block. Lower block experiences mg in the lowermost direction. A normal reaction by the upper block on the lower block, that is equal to nb again, and a normal reaction by the ground on the lower block, that is equal to ng. Therefore ng is equal to mg plus nb. Therefore normal reaction by the ground is equal to m plus small m into g. We will keep in mind these two normal reactions to find out the frictional forces in the future. Now we see, let us consider the motion of the lowermost block in the horizontal direction. This lowermost block will experience relative motion between the ground and relative motion with the upper block also. So it will experience a frictional force by the upper block on the lower block in the right direction. This is because, first of all, this experiences relative motion in the forward direction with the block, due to which the friction of the ground acts in the left direction, that is equal to mu into normal of the ground, that is m plus m into g. Now since this develops a tendency of falling backwards, the friction force by the upper block on the lower block tries to keep the lower block forward and the upper block backward, and it applies a friction force on the lower block in the forward direction so as to counter the frictional force of the ground on the lower block. So this frictional force is again equal to mu by 2 into nb, that is equal to mu by 2 into mg. Now the acceleration of the lower block is in this direction, let it be a. So we write the equation as mu into m plus mg minus mu by 2 into mg is equal to capital M into a. We solve this to get acceleration is equal to mu g upon 2m into 2m plus m. We now know the acceleration of the lower block. Let us write this here. Acceleration is equal to mu g upon 2m, 2 into capital M plus small m. Now we need to find out the time taken by the two blocks to separate. Now if we solve the question with respect to the ground, it will be very difficult, because in the frame of the ground this is also moving and this is also moving. So we do not know the actual displacement to be covered by the upper block in order to leave the block. So it is best to solve this question in the reference frame of the lower block. But the lower block is an accelerating reference frame. So one thing we need to keep in mind is that we need to apply a pseudo force on the upper block in order to apply Newton's law in the frame of lower block. In the frame of lower block of block M, the upper block experiences a pseudo force equal to the mass of the upper block into the acceleration of the lower block, and the direction of the pseudo force is opposite to the direction of the acceleration of the lower block, which was on left side. So this is the pseudo force. The frictional force acting on this block in forward direction between these two blocks will act on this block in backward direction. This is again equal to mu by 2 into mg, and the acceleration of this block will be a dash. Now when we write the equation, it becomes ma minus mu by 2 mg equals to ma dash. We feed in the value of a from here to get the value of a dash as mu g upon 2 into m plus m upon m. This is the acceleration of the upper block in the frame of the lower block. So now let us write equations for the upper block again. The upper block has to cover a displacement of L in the frame of lower block. Now we are solving everything in the frame of lower block. So the initial velocity of the upper block in the frame of lower block was 0, because initially both were moving with velocity v. So the initial velocity with respect to this frame was 0. Displacement is equal to L, acceleration is equal to a dash. Let the time taken be equal to t. We write the equation S is equal to ut plus half at square. This becomes 0 because initial velocity was 0. L is equal to half, a is a dash. So we write it as mu g upon 2 m plus m upon m into t square. T square becomes equal to 4L upon 4Lm upon mu g into m plus m. So the time taken becomes equal to root over 4ml upon mu g into m plus m. So this is our final answer for the time taken by the upper block to leave the lower block. This we have got it very easily comparatively as the case when we would have used the reference frame of the ground to solve the question. So it is always better to solve the question in the reference frame of one of the objects in these type of questions.